Right, man. Thanks. This is a question on 2D momentum. In the game of air hockey, small identical discs move across a frictionless surface. One disc moving with a velocity of 6.9 collide with a stationary disc. After the collision, the disc move apart as shown in the diagram. Before collision, one disc is stationary and one is moving at 6.9. Calculate the velocity v. This is called 2D momentum. So let's
Yeah.
call this as u1, u2 is equal to 0. Let's say call it v1 and let's say call it v2.
Yeah. So
So we have to resolve the angular velocities because there are angles. So I think we discussed resolution in our class, the theory
yeah.
class. Okay, I've done like that. Now help me in resolution.
Mm,
If you make a
okay.
cut here and a made a cut here, you will get 6 cos 30. Remember you told me that you can do it by the method of something you told me, but now I
Sine rule.
forgot.
Sine rule.
Hmm. So I have resolved it. Whatever method you do is fine.
I think I'll prefer this because I have to practice about this because there's some
Definitely
derivation
because it
question.
is in your course. So
Yeah.
this is V1 is 6. I have resolved it.
Yeah.
So now after resolution, I have to apply the formula for x-axis and for y-axis. Let's work out our x-axis working. First, I'm making the equation for x-axis.
Yeah.
X-axis, what's the formula? What's the main formula of this article? M1
V1
U1.
plus M2 U2 is equal to M1 V1 plus M2 U2.
So apply on x-axis. It is U1 is 6.9, U2 is 0. So what is the mass? Mass is given. Um, identical. Look, small identical disk. It means should I keep the masses same?
Identical disks. So yeah, the masses are going to be same. So it's everything M.
Hmm. I'm working on x-axis.
Okay, so M1 would be again M, and then V1 would be 6, and then M2 would be M again. Plus
M2
MV
is
cos
going,
60.
this mass which is V2 is V.
Yeah. Wait, so do we take cos or sine?
I'm working on x-axis
Yeah,
presently.
yeah,
You know?
yeah, 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 yeah. Okay. So you take cos and then is equal to 6 cos 30m. Yeah, 6m cos 30 plus Vm cos 60. Divide all sides by m. So
Hmm. So now can you solve it? What is 6 cos 30 if we make V cos 60 the subject?
yeah, so we
V
solve for
cos
6
60 is equal to 6 cos 30 minus
minus
6.9.
6.9. Yeah. Uh, so I
How
get
much?
minus 1.7.
Minus
1.7.
1.7.
Yeah. I get more digits like 1.7038.
You have divided it?
No, I have not. Then we divide it by cos 60 minus 3.41. That's for x. So then we resolve for the
For velocity,
y-axis.
that's the value for V, na?
Yeah. But then sir, what about the y-axis?
We didn't use it. We are not
Oh,
asked to,
we choose one.
because we have used one equation and it got solved.
Mm, okay.
So we do not need to solve for the second part. Explain whether the collision is elastic or not. Elastic collisions need total kinetic energy before and after collision is the same.
Yeah. Over here, it's the same because it's, I think, a frictionless. So can you scroll up so I can see the question? Yes, sir.
How we verify that collision is elastic or inelastic? I told you that the first method is the total kinetic energy before collision is equal to total kinetic energy after collision. As we have to show working, so I write here total EK. What's the formula for EK?
Half mv square.
Half mv square. So here I will do half m is m. I have two particles before collision. Look, one is 6.9 velocity and one is 0 velocity.
Um, half m.
One is moving at velocity v, other is moving at 6. One is moving at 6, one is moving at 3.41.
Yeah.
Can you help me for making this calculation?
Okay.
Answer can be given in m, no problem.
So I just like cancel out the m's, yeah?
No need to cancel them. They can't be cancelled because I'm not equating them. In terms of m, we can compare now.
Yeah. So I just solve for like half 6 squared,
Hmm.
which is
Other part is
18.
0.
Oh, I'm not doing the total first. Okay, wait, let me do the first one. So the first one is
So forget
6.9.
about m and solve the other equation.
Yeah, so it's 623.81.
23 point.
81. 805 actually.
Hmm.
81 plus 0. And
The
then
second calculation.
It's 18 plus 5.81. It's 18 plus 5.81. I just added.
Add them.
23.81.
Oh, so they are coming equal.
Almost equal, sir, because there's more to it.
Slight difference is fine. It means collision is elastic.
Elastic, yeah.
So this is the plan after the midterm. I'm sorry, after the mock, we can work out together on this file. I have not. I have found a file, but a lot of work is done. But possible I can erase it, or if you can buy this file, I can double check the file and I can send you the link. And you told me you have a digital pen also.
Yeah, yeah.
So that will be ideal if we have a common file. I'm using it. I used it last year. It's a good file. Looking in every paper actually takes time. And for the new paper, in the end, it's good. And now I have done a question on further momentum. I'm now trying circular motion, chapter 14. Two objects collide and rebound. Select the row of the table that is correct for the total momentum and total kinetic energy of the objects in an inelastic collision. Momentum is conserved.
Yeah.
Momentum is conserved, but what about kinetic energy?
Kinetic energy. Um,
When the collision is inelastic, kinetic energy,
it's not conserved. It's not
yes,
conserved.
kinetic energy is not conserved.
Yes, it's B, right?
Hmm,
Sir, is Unit 5 hard?
sorry,
Is Unit 5 hard compared to Unit 4?
I can't understand what you say.
Is the physics Unit 5 the next unit? Is it difficult than Unit 4?
You're talking about unit number 5.
Yeah, yeah. It,
It physics is not very difficult. The problem which I always emphasize is the question. Theory is
yeah,
not
the
that much,
question. Is it like
but
comparatively difficult?
definitely for theory it's much higher. And this is always a standard rule that in A2 theory is difficult. And when you work on any topic, you have to do a lot of past paper. Personally, I believe at least 10 years minimum. Otherwise, you won't be able to get any good marks in the paper. Can you revise the formulas on circular motion?
Circular motion.
T is equal.
Uh, yeah, yeah, I did. Uh, should I like tell them to you?
Last time we did those formulas, no?
Yeah. It was F is equal to mv squared over r. F is equal to mv, no, mrw squared. That's for centripetal force. And we did centripetal acceleration. We did frequency. We did the derivation for time period. We did circular motion. Um, we did motion of a circle, kinetic. Sir, what about the 2D momentum?
2D momentum, we did one question. We have to move
Yeah,
now.
yeah. So you remember the graph, yeah? So it's the VA sine theta one and the VA cos theta. So is there anything like tan related or no?
Hmm?
Is there anything related to tan?
No, tan theta has a formula. Tan theta is equal to y upon x.
So it's not really used in 2D momentum, right?
No, for 2D momentum, we do not need it. Tan theta is not a formula. Actually, it's a type of, you can say, tan theta is a trigonometric function.
Yeah,
Sine
I
upon.
know. I'm saying, is it like related to 2D momentum or no? Like, is
No,
it used?
no, you didn't get my answer. No, it's not a part of anything. It can come anywhere when you need it. It's a trigonometric identity. Now, suppose in
Yeah.
a 2D momentum question, you know the you know the opposite, and you know the adjacent. You use the formula. Tan theta is not a formula for anything, even not
So it
sine
is
theta.
used. So it is
It
used sometimes.
can be used. I remember there was a
Um,
question somewhere, and in that question, uh, it was a motion like this. It was a motion like this and a motion like this, and then we have to use tan theta. So tan
um,
theta is not a part, trigonometry is not part of any formula actually. It's a method to solve a triangle. The
yeah.
International Space Station ISS completes 16 orbits of the Earth every 24 hours. The ISS is 330 kilometers above the surface of the Earth, so that the angular velocity of ISS around the Earth is about this. What's the formula?
Let's see. Yeah, one second. So, 16 orbits of Earth every 24 hours. It's 330 kilometers. Um, so we have like the R, yeah?
We need the time period now.
Yeah. So
24
it's T
or
is equal to,
24 cycle, 24 hours, there are 16 orbits. So I will use 24 upon 16 for time
yeah,
period.
yeah.
How much is it?
One second. 3 over 2 or 1.5.
P over
2.
into 3600, converting it into second.
Oh, yeah, yeah. So times 60, yeah.
Hmm.
So 5400. Sir, it's 5400.
Okay.
Sir, is my voice better now?
Hmm.
Is my sound better now?
It's better. It's like a resonance is there. Sometimes when you speak the words, maybe I have an issue today, but sometimes initially it used to be very clear. but maybe there is a change, something in Zoom. Zoom got updated 1 or 2 days ago, and now it's a slight resonance. Just like sometime I miss the words, but maybe it happens.
Is it
Can
fine now? Is it better now?
it's yes, it's better.
Ah,
Are
okay.
you using a different mic?
No, sir. It's just the Zoom noise cancellation thing.
Mm-hmm.
The Zoom has its own, so it just like cuts off. I
I
don't know
know,
why.
but maybe I have you maybe I'm using a loud volume. This is also a problem. Let me decrease it. Acha. Now calculate the acceleration of the ISS in this orbit. How I find the acceleration?
Acceleration. You can use circular. Centripetal acceleration. A is equal to W squared
Omega
R.
square.
Yeah, omega squared R. So um
You got omega from previous part, right?
yeah.
Have R is 330 kilometer. You understood it, right? Let's move
Yeah.
forward. So this would be the plan once you get this book. If I get a copy, if I can isolate this unit 4 and unit 1, I think I can. But if I get a copy which has no writing on it, then I will share the copy. Otherwise, not a big thing
Yeah, I
because
think if you even give me the copy, I think I can erase it.
but you need the same software and you have to erase the whole day, because this is the new problem with softwares, that if a software has written the ink is from a software, the same software is needed to erase it.
Oh,
Maybe there is a way to erase the whole document once. That's a possibility.
I think I
But
can do it.
anyways,
Just send it
anyways,
to
I,
me.
I can I can get another copy. Maybe I think it's $4 or $5 maximum. It's not an expensive book. It's much better though, much cheaper than those printed books nowadays. Printed books
Yeah,
are very expensive.
yeah, yeah,
So the photograph shows part of the cycling track used in the London 2012 Olympic Games. On the bend, the track is banked so that the outside of the track is higher than the inside of the track.
yeah,
Hmm. The diagram shows the forces R and W acting on a cyclist traveling at a constant speed around the bend. Explain why there must be a resultant force acting on the cyclist.
because weight is acting downwards on the.
No, remember this chapter we did yesterday, but we did it, I know, in a very hurry way. That's not
Yeah,
a way to do anything, but this is unfortunately we had to do that. Actually, when something, this is a cyclic track, it's a circle. If you see this one, no, it's a circle, it's a big
yeah.
circle.
Mm,
It's a big circle of the cycling track using the, so you need it because in a circular motion, you need a centripetal force. So
yeah,
this resultant force is acting on the cyclist. Otherwise, cyclists cannot accelerate. Why a bank track is an advantage? This is just like a question that you must have seen those motorcyclists or bicycle driver. They lean to get into a circle. When they lean, they get extra turning effect and they can lean towards the center of the circle, and this provides additional centripetal force. In a circular motion, the most important thing is the centripetal force.
yeah,
An inflatable airbag helmet for cyclists has been designed to prevent head injuries. It is worn like a scarf around the neck. Inbuilt sensors detect when the cyclist is involved in a crash and inflate the airbag over the cyclist's head in zero point 0.1 second. The graph shows how the force on a cyclist's head during a collision varies with time. It's a force against time graph. Add to the axis the graph that shows how the force on a cyclist's head during collision varies with the time when the airbag is used. Then what is it? Acha, when
Mm,
airbag is not used, oh sorry. Acha, he's saying this diagram is there. Acha, that's why the diagram is going so up. Can you notice the question that he says that
yeah.
without airbag, so the force is rising too much.
Mm.
So if they use an airbag, then if they use an airbag, do you expect the force will be the same high or force
No,
will
it will.
down?
So basically, the force would be at the same height, but then it would be longer. The time would be longer, I think.
The time of contact will increase
Yeah.
and the intensity of the because we need to remember. Do you remember that this area? If you remember this last class, this area actually shows.
Impulse. Yeah.
Yes, this area actually shows impulse.
Impulse would decrease, so the force would be less. No, actually, it would be the same. Force rising would be the same, but then the time would be more. Yeah.
You have to think again. This is a tricky part. It's a helmet around the neck also. I think this is a type of safety measure. You're right, because time of contact will increase.
Yeah. Or maybe like the force would it would be something like this, yeah? Like this.
Hmm.
Can you see the screen?
Time of contact, because area won't change, na? So the force has to come down. I think I agree with you. Any other info given in the question? Acha, this is cyclist in the start. So I think you're right, because the time of contact will increase, the area won't change. So the graph will come down.
The craft would come down, but like in a longer period of time. Because like it
Yes,
would absorb the impact and then
because logically, area will not change.
yeah. Actually wait. So the area would change. No, yeah, it won't change.
Area
It won't.
can't change
Yeah.
like this.
Yeah, like this.
So the maximum force will decrease. Maximum force will decrease. Impulse will be for a longer time.
No, impulse would be the same, but the time would be longer.
Hmm?
Impulse
Impulse,
impulse would be the same.
area under the graph will not change, but the maximum force will decrease.
Yeah.
Let's try a capacitor, because that's also coming Monday. A student investigating capacitor uses the a student investigating capacitors uses the circuit shown. The capacitor is initially uncharged. When the switch is closed, there is a current in the circuit and the capacitor charges. The resistance of the variable resistor is adjusted so as the capacitor charges in order to maintain a constant current in the circuit. After a time of 132 seconds, the capacitor is fully charged.
Yeah.
Okay. Show that the capacitance of the capacitor is about 5000 microfarad, sorry. So Q, should I use Q is equal to CV or should I use tau is equal to CR, the time constant?
The time constant. Yeah, actually, I'm not that good with formulas. Kind of slow.
Hmm?
I'm not that good with the formulas, so like, need to.
So you have to,
So,
because we have written all the formulas now. So you
yeah,
have
we
to,
have written, but like,
I
I
mean,
have to like go back to the notes and
you
look.
have to learn the formulas.
Yeah. Okay, so we need a formula for what?
Capacitors has a Q is equal to CV. One formula is this. What's the formula? Q is equal to CV. What's the Ohm's law formula?
The Ohm's law formula.
Look at the screen.
Q is equal to CV is equal to IR. So we need to find current, yeah. So
We need C.
we
The
yeah we need
problem is
C.
that
We have voltage, sir. We have
I
charge too.
have, there is a current. Do I have the current? No.
Okay. But sir, to find
I have V, but I do not have Q. Do you remember the formula? Q is equal to I into T. I have the time.
yeah, Q is equal to I into T. Yeah. So we can find current from dividing V over R. So 6 divided by 28,000.
And I will put here to find Q.
Yeah,
And I need C. I actually have to find C is equal to Q upon V.
yeah,
So from here, I get Q.
yeah.
Explain whether the resistance of the variable resistor is steadily increased or steadily decreased in order to maintain a constant current. This question is a bit tricky because explain whether the resistance, or actually you have to recall all the formulas of current last year, current, electric current, power, energy, Ohm's law, etc. Explain whether the resistance of the variable resistor is steadily increased or steadily decreased to maintain a constant current. When a capacitor is on charging, if I recall, when a capacitor is charging, the circuit current gradually decreases. This is how a capacitor charges. When a capacitor is charging, its current gradually decreases. So it means by rule, circuit current decreases. He wants, what he wants to have a constant current, but current is decreasing. So it means I have to compensate for current. So what should I do? Should I increase the circuit current to compensate for the loss of current, or should I decrease the circuit current? Should I
Decrease.
increase the circuit current or decrease? Because itself current is decreasing and I want to have a constant current.
To increase the current, sir.
I have to increase the current. Very good. I have to increase the current. Acha, if you want to increase the current, look at this rheostat. Should I decrease the resistance of rheostat or increase it?
Rheostat, resistance, decrease the resistance.
Resistance and current are inversely proportional. Na? When you increase resistance, current decreases. When you increase resistance, current decreases.
Yeah,
So what should final answer? I will decrease the resistance of the rheostat, current will increase, and this increasing current will compensate for the decrease in current in capacitor. So capacitor current is decreasing. So I will increase the circuit current to compensate for it.
yeah.
So you must have noticed that these questions are quite challenging. And here we have a very uh, interesting interpretation that how we improve past paper question. The answer is very interesting. Do more questions. This is just like how you improve your driving. So you learn some basic rules, lessons, etc. But after all safety measure, then after that, only one thing is there, drive more. So you gradually get it, list the skill. So do many questions as much as you can. I have noticed that this file has 2015 to 2019. This is not
19.
a big range, but still, it looks to be organized.
Yeah.
A textbook states in a circuit with constant resistance, the time to fully discharge a capacitor is equal to 5 RC. Show that RC has the unit of second.
So RC is resistance and capacitance. Yeah.
This is last year work now. R is resistance, omega. C is capacitance, which means what's the unit of C?
Uh, so R is V over I. No, wait. Let's go for capacitance. Capacitance
But what
is,
about ohm? R is equal to V upon I,
yeah.
which
uh,
means
And the
volt.
capacitance is V, Q over V. So it's,
Capacitance is C is equal to Q upon V.
yeah, so it's charge upon voltage.
Coulomb per
V,
second.
V.
No, no, no. Sorry, Coulomb per volt.
Yeah. So it cancels out V and, so it's
Coulomb per
C
ampere.
upon A. Yeah. And
And
I,
ampere is Coulomb per second.
yeah. So just per second. Yeah.
Evaluate the statement from the textbook. Your answer should include a suitable calculation. What is this?
Huh? Wait, isn't it the same thing?
A textbook states in a circuit with constant resistance, the time to fully discharge a capacitor is equal to 5 RC. I have the R, I have the C, I can multiply it and
Yeah,
see
but
what
like
time
it
I
says
get.
the resistance is constant, yeah?
Huh.
So,
But you have the resistance in hand in the previous part.
yeah,
What's our resistance?
our resistance is,
28.
yeah, 28 kilo ohm. But yeah, I think that's like a different part. I don't know if it's related to that.
Different part. If it's a different part, then how we can calculate what's the
I think
I
it's just telling to evaluate. So
hmm?
no, it says to calculate too.
But we need some values now.
Yeah.
So do you remember the topic of exponential discharge of a capacitor?
Exponential discharge.
You're right. This is not related with part B. So Q is equal to Q naught minus T upon R C.
Oh yeah, this one. I remember this one. It's in the formula booklet.
So you have to sit and revise all the formulas. Uh, I have this formula, but I don't have Q and Q naught. But at least I have a formula and I can find the percentage. What is the time constant value? So we can make a ratio. Should I take ln on both sides? You take mass also, I think. So how should I get rid of this Q naught? I want to make it Q upon Q naught. And it is this formula. I can take ln also on both sides. Time constant is given 5 RC. Now this is the working. Can you solve it using calculator?
Yeah. There's 6.74 times 10 raised to the power minus 3.
6.74 10 power.
Minus 3.
So I want to make it a percentage.
Time. So, oh, percentage times 100. 0.67%.
So it's a very little, even not 1% is discharged.
Yeah.
Even 1%
1%.
is not discharged. So should I say the textbook is right or textbook is fairly wrong?
Wrong.
Right, the textbook is wrong. So we stop here. We did a question on that. Ideally, I will send you the last year, year 12, the current formulas now, because I think you have to revise them. Some of them are there, some of them you remember, but you might have missed some of them. It will be very advisable, which because I'm not getting enough time to scale the work because always we have to come because suddenly the mock is announced that you have to make a
Yeah, the
folder which
mark
I
really doesn't matter, to be honest.
Hmm?
Like, it doesn't